Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're going to do part 2 of our series on customizing UIs. And in this tutorial, we're going to take a dial that looks something like this, which is the default Juice look and feel, to something like this, which is a dial that I've customized myself. Before we get started, just wanted to let you know about our audio programming community on Discord. It's a great way to connect with other audio programmers around the world and learn from each other. And you can join us on the audioprogrammer.com/community. So let's go ahead and get started. So here we are at the point from our last tutorial. And if you'd like to follow along, you can actually check out the GitHub repo, which I will put in the description below. And all we have here at the moment is just a blank black screen. And first thing we're going to do is we're just going to change the size and the background. So I'm going to change this from 600/400 to 400/400. And I'm going to change the background from black to gray. So this is something that you can customize to the color of your choice, but this is just what I'm going with. So square background, and it's gray. Now the next thing we need to do is we need to make a slider. So let's just make a Juice slider. So we will do this, and we'll just call this my slider. Now I'm going to give the slider some specifications here. So we can say my slider, set slider type, set slider style, and this will be Juice slider, slider style. And we are going to go for the rotary horizontal vertical drag. And I've covered the sliders in the past, just in case you're wondering how I'm getting this. And if you want to check that out, I will put a link probably up in the top right hand corner. So another thing that we'll do is my slider set range. We'll make the range 0.0 to 100.0. And my slider set value, we will just start it at 25.0, just picking out some random values here. We will add and make it visible. And now we will just draw it to the screen and resize. So I will say my slider set bounds. We'll put this in the middle of the screen. So we could do get width divided by 2 minus 100. Get height divided by 2 minus 100. 200, 200. So this would be a 200 by 200 rotary slider. And another thing I'm going to do is I'm going to get rid of the text box for now, and I'll come back to it a little bit later. So I'll go my slider, set text box style, and this will be Juice slider text box, no text box. We'll make this read only, even though we won't even see anything. And then I will just make this 100 pixels by 25 pixels. Like I said, you're not going to see this. So let's see what we got now. So we should just have a standard slider now. So there we go. This is our standard slider. Not much to see. Great. So now we're going to jump into the API and see what sort of aspects of the slider we can customize. So currently I'm in the slider look and feel methods struct. And these are the methods that you can use to override to actually customize these as you see fit. So any of the classes that say look and feel methods are ways that you can actually customize certain UI widgets. So in this case, I'm looking for a new way to actually draw this rotary slider. And we have this virtual method called draw rotary slider, where we can actually override this and draw it ourselves. So what I'm going to do is I'm going to copy this, And the question you may ask is, where am I actually going to put all this? So this is going to go into our custom look and feel class, right? So custom look and feel class is overriding the Juce look and feel v4 class. That's what we did in the last tutorial. So now we want to say, okay, what do we want to make unique about our custom look and feel class that's going to be different from look and feel v4? And this is going to be one of the methods that we're going to override. So I'm going to do void draw rotary slider. For time's sake, I'm going to wrap this all in a namespace Juce, so I don't have to type Juce every single time. So wrap this whole class in namespace Juce, like that. And there we go. And then I'm just going to do the same thing for the CPP. So we do namespace Juce, all that inside. And then in here, we're going to do void, and the name of the class is custom LNF. And then I'm just going to paste all of that again. And we just have a blank method, right? So nothing in here. And in here is where we're actually going to customize how our slider is going to actually look. A rotary slider. And you'll see that if we just build this quickly, we will see that there's nothing there, right? So there's currently nothing there because we haven't actually defined how we're going to draw a rotary slider. One other thing that I'm going to show you that I did quickly is that when you wrap things in namespace Juce, now that custom LNF class, because that's in namespace Juce, you've got to do the Juce custom LNF. Okay, so don't forget to do that. So now the question is, how are we going to draw this rotary slider? And if you're just getting started, this could be quite a daunting task. So what I would advise to do is some of these look and feel methods, they have default ways that they draw. So we had a default way that draw rotary slider was actually drawn, and we can actually look for that. So if I go back to the header file and I go into look and feel v4 and jump into definition, I'm going to go to the CPP file because that's where all the function definitions are, where we actually implement those. And I'm going to do a search, and I'm going to search for draw rotary slider. And you see that we have a default way that this is drawn, right? So it looks pretty complex, right? If you're just getting started. So what I'm going to do is I'm actually just going to copy all this. Copy. I'm going to go back to my own code. I'm just going to paste it for now. All right, just pasting this in. And what do you think what do you think we're going to see now when we actually build? Okay, so 1 moment. So I just need to make this G, and this needs to be called slider. Okay, I think we're okay now. Slider pause. I should have taken the whole function call with everything, with the actual function name and everything. There we go. We got build succeeded now, and now we have our slider again. Okay, and that's it. That's because we've just pasted in the same code that we had in look and feel v4, and that is yeah, so that makes sense, right? So what I like to do here, the way that I think is a great way to do this is to look through this code, and especially if you're just starting out, to actually just do little comments above just to show, okay, this is where certain parts are getting drawn. So for example, background arc. So if we just put these side by side, and we're just going to take this code and we're going to actually break it down. So the background arc is actually just this arc here. Okay. So I don't know if you could tell, but the color slightly changes when when this slider, as the slider goes around. So this background is what we're talking about here. So that is just slider path background. Should I call it a dial? Dial background path. So everything above that is just local variables that we're that we use throughout this function call. Okay, so here we've created a path. You add a centered arc. You set the color, and this is where you actually draw it. And then here we have the value arc. So that is the other arc. So you can't really see. So this is where it turns really black. And that is this value arc here. So now let's just do that. So we will call this dial fill path fill. What did we call this here? Dial. I'll call this dial fill path. Okay, so this is, once again, we got the same sort of thing. A path. We're adding a center arc. We're setting the color of it, and then we're drawing it. And then we have thumb width. Okay, then we got this thumb point. So the thumb point is just this, the actual thumb, the actual circle. So now we're creating a juice point, and we're defining what that is using this fancy math. And then we're setting the color to whatever the slider thumb color ID is. In this case, it's blue. And we're drawing a circle there. So now we're going to do that. And we will just call this, I'll just call this thumb. So pretty easy going once we've actually broken that down. You got a background path, a fill path, and you've got a thumb. And that's really it. So now we're going to start customizing this. So one of the first things that I'm thinking about is, how do we draw a line that will go out from the center of this background arc to where this thumb is? So the Juce team have been nice enough to do the hard work for us in this scenario, which is finding where this thumb needs to be along this path according to the value. And all we want to do is just take a line and draw it from the center out to where the thumb is. So now how do we find the center? So we know that this background arc is of type path, because that was what was created earlier. So Juce is really nice because it has a lot of handy functions for finding the center of things and finding the width of things and things like that. So first thing that we'll do is we will draw a line. So we'll do G draw line, and I'll use this one that has a thickness argument at the end. And first thing that we can do is we can look to the path class and see what we can find in path, if there's a way that we can get what the width or what the bounds of this is. And you can take a look, now that we're in the API, that in the path class, we indeed have this method called getBounds that returns a rectangle, right? And then if we go into the rectangle, then what we could do is we can look, and we have all of these handy methods: get X, get Y, get the bottom, get center X, get center Y. That's exactly what we need, right? So we just need to do a little bit of function chaining to get to where we want to go. So we're going to say background arc. Then we're going to do get bounds, which returns the smallest rectangle that contains all the points within the path. And then dot get center X. Okay. And then what do we need to do for the Y coordinate? So once again, background arc, get bounds, get center Y. That's it, right? And now we just need to find this thumb point. So this is of type point. Point is just a fancy way of holding both an X and a Y value in one data structure. So now we can say thumb point get, shall we try get X? And then thumb point get Y. And then for line thickness, they have this variable up here, line W. So that's just how thick the that background, the arc line is. I think that's a good thickness for our line as well. And we will just use that. So it will be line W. And now we will just need to capitalize this W. Build this. And let's see what we got. So there we are. We now have a line drawing from the center of this arc, extending out to where the thumb was. Fantastic. So this is great. This is a great start. So now we can just get rid of this, and we're not using this thumb width anymore, so we can get rid of that. And I will just relabel this line. So the next part of this lesson is learning how to draw the slider or the dial at a different angle. So we're going to switch the angle. And what I've done here is I've actually gone to the Juce slider class to take a look here in the documentation. And we can see that we have this struct that's within the Juce slider class called Rotary Parameters. And this is a convenience function that they've actually added so you can change this relatively easily. The only thing that you need to decipher is how to actually calculate the angle. So just reading in this, we can see that we have this on line 146 where it says the angle at which the slider's minimum is represented. And then down beneath here, it says the angle in radians clockwise from the top. So this clockwise from the top is actually a key part of this documentation. It's very important that we realize that. If you actually go and you look up the circle in radians, you will normally find that the radians is calculated from the right or from some other place other than the top. So what I've actually done here is I've actually very roughly drawn what this actually looks like. So as we can see up here, and I hope that you don't mind my messy handwriting as I try to write this and speak at the same time. So right here we have the very top of the circle, which is going to start at 0 or 2 pi. So now what we need to do is we just need to calculate the angles that we need our slider path to be. So going back just a second to the actual code, one thing that you'll see is that one of the first things that I thought is, well, how did they calculate the angle that we have right now? So if we just take a look here and we actually compile this. So the next part that we're going to do in the tutorial is how we're going to turn the slider to make it start at the very left, where the minimum is going to be on the left, and then it's going to curl around, and then the end point is going to be at the bottom. And if you're a bit afraid of math or intimidated by it, don't worry, this isn't going to be too heavy, and I'm going to explain it as intuitively as I possibly can. So just follow along. So one of the key things that I think intimidates people to start off with is that the angle is going to need to be calculated in radians rather than degrees. Normally most people think in degrees, but this is in radians. But it's actually quite intuitive once you get used to it, and I'll show you how. So going here to the code, we see that in the slider class, so we're currently in the Juce slider class, there's actually a convenient struct here called Rotary Parameters with float angle radians and end angle radians, where we can actually define the starting and ending points of where we want the slider to be. So if I build this very quickly, then we will take a look and we see that it starts at the moment at kind of 7 o'clock, ends at what I would describe as 5 o'clock. And so the first thing that I thought is, well, how did they calculate these? Let's take a look at that. Maybe that could give us a clue in terms of how we need to calculate ours. So going into the slider CPP, into the constructor, we see that we have some default values that have actually been set for these. So we have pi times 1.2 and pi times 2.8. And that's what gives us this starting and ending position of 5 or 7 o'clock, and kind of 5 o'clock respectively. Now the question is, well, how did they get that? So let's see if we can just dig into a diagram here and actually have a look at how they actually came up with those numbers. So I've actually kind of terribly drawn this unit circle. And one thing that you'll find is that if you look up the unit circle or the circle in radians, you'll find that the 0 actually starts off typically in most diagrams on the right hand side, whereas in Juce they've calculated it from the very top of the circle. So that's why I've needed to kind of draw that. Now, one thing that is really awesome about using radians versus degrees is that all you do is for every kind of what I would call 90 degrees that you go, you add half of a pi, right? So a circle, most people know that that the radius of a circle is 2 pi. So 1/2 of that would be 1 pi, right? And that makes sense. And if I took 1/2 of that, then that would be pi over 2. If I took 3/4 of that, that would be 1.5 pi, right? So it's pretty intuitive. Every 90 degrees, you just add half of a pi. And that's and then that makes sense. So if we take a look here at this and compare it, sorry, I need to go back and forth between the code and the diagram. So taking what we just spoke about and taking a look at what we have here, then we can say, okay, well, this is pi and it's 1 pi, right? So which brings us to the bottom of the circle. So let me pull this back over here. So 1 pi would bring us to the bottom of the circle. And then he has, the Juce team have added 0.2 to that. Okay, so which means that we have 0.2 pi, which means it's going to be just a little bit further than pi. How far past pi? 0.2 past pi. So it would be kind of right here, right near where this 5 pi over 4 is, which is actually 1.25 pi. So just a little bit less than that. Same thing with the end angle, right? It's 2.8. Well, why is it more than the start angle? Because what we need for the end angle to be larger than the start angle. Otherwise, we will get the slider happening in reverse, which we do not want. So that's 2.8 pi. So let's calculate that and let's look at that. So we start at 0. We go around the circle one whole time. That brings us to 2 pi. And then 2.8 pi means nearly 3 pi, but not quite. So that's how we get down to what is down here. So this is 0.75 pi, right? So it would be just right here. You probably can't see my mouse, but it's 0.8 pi. So right near the bottom, nearly halfway between pi over 2 and pi. So that's how they've come up with their calculations. And now we just need to come up with our own calculations. So this is not going to be too bad if we think of it in those terms. So the first one is just going to be right here. So we're starting at the very left-hand side. Once again, we are going all the way around the circle, and we have this every quote-unquote 90 degrees, we're adding half a pi. So we got pi times times 0.5. Then we got 1 times pi. And this would mean that this is 1.5 times pi, right? So a pi and a half. So we got our first angle here. Now comes the challenging part, which is that we need to calculate the angle that we need down here at the very bottom. Well, it's not too bad. Like I said, the key is that it has to be more than 1.5 times pi, which means that we need to go all the way around the circle, which will give us 2 pi, plus, and then we just go 1/2 around the circle again, which gives us another pi that we need to add to it. So 2 pi plus pi equals 3 pi, or pi times 3.0. That's it. That's all. That's how we calculate it right there. So that's so as simple as that. And now we just need to actually convert that into code. So the first part of drawing our slider at that new angle is actually getting those rotary parameters that I showed you earlier, so we can actually change those. So we have a function here called getRotaryParameters that's in our slider class. So that's one way that we can actually grab that. So what I will do is I will go into my main component here, and I will get those params. So I could just say auto Rotary Params equals my slider get Rotary Parameters, and that returns my Rotary Parameters. And now I can change those. So I could say Rotary Params dot start angle radians, and now I just put my start angle radians. So I just need to go back to into here just to remember how to actually write pi. So it's this math constants float pi. So I'll just copy that right there. Okay. And we just need to put a little Juce namespace before that. And we just plug in our numbers. So that first one that we needed to plug in was 1.5, right? So 1.5 3 over 2 pi radians. And we go into rotary params and angle radians, and we just plug in that number that we just calculated just a second ago, which is going to be this Juce math constants pi times 3, right? So it's 3 pi. And now we just need to set our rotary parameters. So we say my slider set rotary parameters, and we just put our rotary params in there that we just changed. Let's build it and see what we got. And now you can see we have our new slider that starts on the left-hand side and ends at the very bottom. And that's really it. That's really it right there. So now what we can do is we see that this bleeds a little bit into the actual arc, and you can go in a whole multitude of different directions here. And what I've done here is I've actually just taken a little bit off of that line. So and I had to actually do some calculations and some experimenting around to find what that was. And I have to do it in here because if I try to do it in the draw line, the length of the line actually changes depending on where you are on the arc. It's a little bit complicated to explain, but I don't want to waste your time in trying to explain it all. But yeah, through a little bit of experimentation, I actually came up with this. And now we are the same distance from the line, no matter how far around we go. And now let's just do a little bit of styling on this. So this is where it starts to get fun. So we can now say, we can go back to our slider documentation here, and we will see that for our color IDs, we can change a whole load of these, right? So we have background color ID, we have the Rotary Slider outline color ID. I'll leave that the same. We got the Rotary Slider fill color ID. So let's go for that. Right? So that's going to be what the fill is going to be. So we can use the method mySlider set color, and then we have to go down the line, Juce, Slider, and then we're in color IDs within Slider. And then this is Rotary Slider fill color ID. Now we just need a new color. So let's do Juice colors orange here. We will build that. See what happens. And we see that we now have the fill color is orange. So there we go. So let's change the actual line to orange as well. So let's take a look at how that's actually drawn. So if we go back into the style sheet, so this is what we've drawn ourselves, and we will see in our line drawing that the color is set from the thumb color ID. So that's what we need to do here. So we will say mySlider set color, Juice, Slider, color IDs, thumb color ID, and we will just do the same thing. Juice colors orange. We'll build again. And now we have something that's closer to our final result, which is this slider. So there's one final thing that I would like to do. So what if I want all of my sliders to be like this? This is going to be a pain having to write all of this business for every single slider that I create, right? So I've only created one, but now if I try to create a second slider, if I want that second slider to be the same as this first one, it's going to be a real pain if I need to do all of this again. And that's not what we want. We want to have one slider where every time we create our own custom slider, that is going to create this design. So what I will do is I will actually put this in my style sheet. So style sheet is where I'm going to put all of my custom stuff. And let's create a class. And we're going to inherit slider, because our slider is going to be a type of Juice slider, right? We're just inheriting from that class. So I'll just call this let's just call it custom dial, and we will inherit from public. I don't need to actually type Juice, but so I'll just type slider. And we will make a public place and a private. And there we go. So now what I could do is I could actually take a lot of this code and I can actually just cut this, and I can actually toss it in this new slider class. So I'm going to create a constructor. I'll just do it here in the header file since it's just a few lines. I'm going to paste all of this stuff. Now it's saying I don't know what my slider is, right? Because this custom dial class is a slider. So because of that, I could just take all of this my slider business, and I can actually just take all of that off, because this is a slider. then, so we would just get rid of all of this business. And so this is a custom dial class. And now what I could do is I could go to my main component header. And now rather than a Juce slider, this could be Juce custom dial. Right? And maybe I'll just change this to my dial. And then here we go. We will make this my dial. And that cleans things up quite nicely, doesn't it? Our constructor is now only 3 lines of code. We will build. And we see that we have our slider. So now that's turned into our custom dial, and we can make as many of those as we want. So if we want to make 10 custom dials, we could do that, and they're all going to look exactly the same. And that's it. So it makes it nice and extendable. So that's it for this tutorial. So I hope you enjoyed this tutorial. And if you have any questions, be sure to ask them in the comments. Or if you have more creative ways of doing this, then I would love to hear your advice and ways that we can get better as audio programmers. So thank you. Be sure to give this video a thumbs up and subscribe, and we will see you next time.